Let's talk about how some of those bright lights you see, like street lights, stadium lights, and lights in parking lots, actually get started. If you've ever noticed a delay or flickering when these lights turn on, that's because it takes a little more effort to get them going than regular light bulbs. Today, we're going to break down how mercury vapor, metal halides, and high-pressure sodium lights work when they start up. First, let's start with mercury vapor and metal halide lamps. These lamps have something special, a starting electrode. Now, this is just a fancy name for a small part inside the lamp that helps it turn on. Think of it like a little helper that gets the lamp going. It's placed next to one of the main electrodes inside the lamp's arc tube, which is where the magic happens. When you turn on the lamp, an electric field is created between the main electrode and the starting electrode. This electric field causes something called electrons to be released, which then ionize the argon gas inside the lamp. Don't worry too much about the science words. Just think of it as the gas getting charged up, making it easier for the lamp to light up. Now, this charged up gas creates something like a mini lightning bolt, an arc between the two main electrodes inside the lamp. The heat from this arc starts to vaporize the metals inside the lamp, things like mercury or halide compounds. Once enough of these metals vaporize and join the arc, it creates a steady flow of electricity, and that's when the light finally comes on. But here's the interesting part. All this action, these rapid movements and collisions between the particles, creates light. And because so many particles are moving so fast, it looks like the whole arc tube is glowing continuously. Now, let's talk about the color of the light. The type of metal inside the lamp determines the color. For example, mercury vapor lamps give off a greenish-bluish light. Metal halide lamps, on the other hand, have a more white-green light. These lamps can also have a phosphor coating to improve the color and the spread of the light more evenly. Once the lamp is up and running, the voltage inside the lamp drops to the normal level, and the starting electrode is no longer needed. It gets shut off by a resistor or a thermal switch to make sure it doesn't get damaged while the lamp is on. Okay, now let's shift gears a bit and talk about high-pressure sodium lamps. These work a little differently because they don't have a starting electrode like mercury vapor or metal halide lamps. Instead, when you turn on a high-pressure sodium lamp, it needs a huge voltage pulse to get started, kind of like a jump start for your car. This pulse is usually between 2500 and 4000 volts, way higher than the voltage in other lamps. This pulse helps ionize the neon gas inside the lamp, creating an arc between the two main electrodes, just like in the other lamps. As the arc gets going, the sodium and mercury metals inside the lamp quickly vaporize and mix into the arc. stabilizing the current and making the lamp shine steadily. But here's the kicker. High-pressure sodium lamps give off a very yellow-orange light, with a bit of green and blue mixed in. It's that classic streetlight glow. Now, all these lamps, whether mercury vapor, metal halide, or high-pressure sodium, have something in common. They all need a ballast to work properly. A ballast is like a traffic controller for the lamp. It helps regulate the current so the lamp doesn't draw too much power and burn out. Without a ballast, the light would go crazy and quickly get destroyed. So, in short, each lamp uses a different way to get the arc started, whether it's using a starting electrode or a huge voltage pulse or something else. But once they are on, they all rely on the ballast to keep the current just right so they can continue to shine brightly and safely. Next time you see those bright orange streetlights or white lights at sports stadiums, you'll have a much better idea of what's going on inside to make them shine.